So today we're going to be studying scientific notation. Our objectives are we're going to be looking at how can we represent normal numbers or standard notation into scientific notation, and how can we convert scientific back to standard. So what you need to know about scientific notation is that it's a way to write numbers using a power of 10, which is what our number system is based on. It's usually used to express very large or very small numbers. So what we're thinking here are numbers where we have something like 0.000005 or 521 million. Okay, these numbers have a lot of digits, and so when we go to try to put these in data tables, we need them to be able to fit. Okay, and we need our calculations to not look so overwhelming and complicated with all the zeros. So we use scientific notation in order to do that. So there are three key parts that you need to know when writing scientific notation or interpreting it. So first, there's always a number that is less than 10 but at least 1. So an easy way to remember that is that you only have one digit in front of that decimal place. The next piece is that you have a times 10. So as you can see in both of our examples, we have times 10. And finally, we have an exponent. This can be either positive or negative, and they mean something. Positive exponents are for large numbers. So large numbers means more than 10. Small numbers are things that are going to be less than 1. And then finally, if we have something that is at least 1 but less than 10, so once again, our large numbers are 10 and up, and we get that positive exponent. Then we have 1 and lower, and that gets a negative exponent. So in between, we actually get an exponent of times 10 to the 0 power. So we have some simple steps in order to write a number in scientific notation. So given a standard number, we can put it into the scientific notation with these 5 little steps. First, you want to locate that decimal point. Then you want to move it to a location to get it between 1 and 10, or have one number in front of the decimal. And then you want to write down this new number followed by times 10. Count how many times you have to move the decimal point. Use this number as your exponent. And finally, you're going to decide on the sign of your exponent. Our larger numbers are going to be positive. Again, large meaning that it is greater than 10. And then smaller numbers are going to have a negative exponent, meaning less than 1. Okay, so numbers that are less than 10 but at least 1 will have that exponent of 0. So those would be our whole numbers. All right. So looking at our couple examples, they're showing you right here that we have 3,500,000. And writing that in scientific notation, they first started with finding that decimal point. So as you can see in this first example, it's a great example because this happens a lot. You don't see a decimal point. So what you can do is you just add one to the very end, and now we've located our decimal point. So put it at the very end of the number, you've got your decimal point. We need to move this decimal point to where you only have one number in front of it. So we are going to move it right behind that 3. Then we would write that number 3.5 times 10. Now we're going to count how far away we had to go. So we had this decimal, we went 1, 2, 3, 4, 5, 6 places. So we're going to put the exponent of a 6. We're going to look at this number, and this number right here is greater than 10, so we're going to leave it alone as a positive exponent, and then it's done. Same thing on this other one. We found that decimal. We needed to move it behind that 4, so they did that. We now have 4.67 times 10. In order to figure out that exponent, they counted it to show 1, 2, 3, 4. So we put the 4. We recognize that this is less than 1, so we're going to go ahead and follow up with a negative sign. So for our next example, we're going to look at 0.000000, all these zeros. So this is definitely not something that we would want to write in our data table. So looking at this, we're going to take that decimal, we are going to move it. So we found our decimal, we're going to move it behind one of the digits, so we only have one number in front of it. We're going to rewrite that number, 5.06 times 10. We're going to count how far it went. So we had 1, 2, 3, 4, 5, 6. We're going to put that number. Then we're going to look at what we've got. This is a small number. It is less than 1. So we have to add in that little negative sign, and now we're done. For our last examples, we're going to now look at scientific notation, and we're going to put it back into standard. So it's pretty much the same steps, except we're doing them backwards. So the first thing we're going to start with is we're going to recognize by using that exponent whether something is going to be large or small. So we're going to look at whether it's a positive or a negative exponent. So remember, a positive exponent tells us that it is a large number, meaning that it is greater than 10. A small number is going to have a negative exponent, meaning that it is less than 1. Once you've determined if it's big or small, you're going to determine which way to move the decimal. So if I have something like 1.5, if I need it to be a big number, we would want to move it to the right. So therefore, large numbers, you're going to be moving that decimal to the right. If I have the opposite going on, so if I want something less than 1, you move it to the left. And that'll be what we're going to be doing with these examples. So move the decimal point the number of times the exponent says to, and then write the number you now have. Okay, so for our first example that they've got right here, we have 4.59 times 10 to the 7. We need to write that in standard form. So the first thing we're going to recognize is that this has a positive exponent, so we can see that this 7 is a positive number, meaning that it is a big number. So once we've determined that it is a big number, we know that we have to move that decimal to the right in order to show that big number. So we're going to take that decimal, we're going to move it to the right 7 times. So you can see here, we had that decimal right here in between the 4 and the 5. We have 1, 2, 3, 4, 5, 6, 7. And so now we're left with 45,900,000. Similarly, when we have the opposite going on, we have something with a negative exponent. We're going to take that negative. We know that that means it needs to become a smaller number. So we have 2.14. We need it to be less than 1. So we're going to move that decimal off to the left 3 spots in order to make this number. So just like what we see here, we had that decimal right here. We went 1, 2, 3 spots to end up with that 0.00214. So to try one on our own, we've got this 8 times 10 to the 8th. So I'm looking here on number 10. If we have 8 times 10 to the 8th in standard form. So I'm going to look here. I have this exponent. I have a positive 8. So that tells me it should be a number that is greater than 10. So it should be a big number. So that means I'm going to move that decimal. Once again, we have another example where a decimal isn't given to you. So put it after the number. We're going to move it to the right to make it a larger number. And we're going to move it 8 times. So I have 8. And now I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8. And now what you do that we didn't see in those examples before is you take all those little bumps and you're going to put little zeros in there. So 1, 2, 3, 4, 5, 6, 7, 8. And so we would end up with an easy way to figure out what this number is you go every 3 from the decimal. So 1, 2, 3, comma, 1, 2, 3, comma. So we have 800 million in this example. And that would be the answer for this one. Looking at number 11, we have 2.97 times 10 to the negative 2, so we know that this is a negative value, meaning it is a small value, so we need to move that decimal off to the left. So I'm going to have 2.97. I'm going to take that decimal and we're going to go 1, 2, put the new decimal there, fill in with zeros, so our answer is 0.0297.